Hi everybody, and welcome to the next video on loops. So we've now spent some time working with while loops, and you are now somewhat comfortable with those. In C++, there are actually three kinds of loops. There are while loops, which we now know. There are also for loops and do while loops. So the logic behind all three kinds of loops is the same. I mean, a loop is basically just a block of code that will run until a statement is no longer true. Okay, that's true of any loop. Just the same block of code runs over and over again until some condition becomes false. So the difference is syntax. And the difference is also is when you use what kind of loop. So I want to show you these other two kinds of loops, and I want to show you their syntax and talk about when you would use what kind of loop. And the syntax of the do while loop is pretty simple if you know what a while loop is. A do while loop is basically just a while loop. The syntax of the for loop, though, is, well, it takes a bit of getting used to. So we'll spend most of our time on for loops in this video. So here's the setup of a do while loop. You write do at the top, and then the code that you want to loop is inside the braces. And then the Boolean statement that determines whether or not the loop runs again comes at the bottom of the loop. So what you're telling the computer to do is do this code as long as, right? You can read while as long as. So do this code as long as this statement is true. So it's basically just like a while loop. Notice though in the syntax setup here, the do while loop closes with a semicolon. Okay, so this is confusing and perhaps surprising because if statements, you don't put a parenthesis after you don't put a semicolon after the parenthesis. And while loops, you don't put a semicolon after the parenthesis. So why do you have to put a semicolon here? Well, because the designers of C++ say you do. You know, I don't have a better answer than that. But one of the most common errors that people have when using a do-while loop is to forget that semicolon there. And it's a natural mistake because why would you have a semicolon there? So note the semicolon after the while. Okay, so when the computer encounters a do-while loop, what it does is it immediately enters the braces. So when the computer encounters a do-while loop, it's going to run this code. The question is whether or not it runs it again. And it will run the code again if the statement is true, but if the statement is false, it won't run the code again. So basically, if you set up a do-while loop, the code inside that do-while loop will run at least once. Okay, the computer is going to do this code. The question is, does it run more than once? That is in stark contrast to while loops, which we're used to now. If you have a while loop, then if the statement inside the parentheses is false, the computer doesn't even go into the while loop. It just skips right over that code. In a do while loop, it's going to run this code no matter what first, and then check whether or not the statement inside the while is true. So it sort of reverses the process of a while loop. In a while loop, you'll say, you know, while statement and then code. It will check whether or not that statement is true first, and then enter the braces. In a do while loop, you enter the braces first, and then afterwards check if the statement is true to decide if you're going to loop back to the beginning. Okay, so that's the only difference between a do while loop and a while loop. In a while loop, again, you check whether or not the statement is true or first, then go into the loop. In a do while loop, you just go right into the braces, and then at the end of the first pass through the braces, you check whether or not this statement is true. So, a do loop or a do while loop, whatever you want to call it, always runs once. Okay, you're always going to do this code once. The question is whether or not you run it more than once, and that depends on whether the statement here is true or false. And essentially, a do while loop is just a while loop that's guaranteed to run once. So, since that's true, since a do while loop is basically just a while loop, right? You might wonder, why do we even study them? I mean, why are they even there? So let me just show you an example. This is the factorial calculator from last time. So just to remind you what it does, you know, you enter a positive whole number like 5, and then it outputs the answer, the factorial, and then it asks you if you want to go again. So I'll say yes, and then enter 6, and it will tell me yes, enter 7. Okay, now I'm done, so I'll enter no, and the program exits. Okay, that's what the program does. So if you look at the code itself, what happens here is I initialize a response to yes. Now response is yes, so I enter the loop, and then I go on down, and then at the very end of the loop, I let the user update their response. So if the user still wants to keep going, they enter yes, and then I loop back up to the beginning. But if they answer no, then I break out of the loop, and I just keep going in the program, and since there's nothing here, the program just exits. If you think about the logic of what's happening, though, when the program runs, you always want to run this code here at least once. I mean, this program is a factorial calculator, so of course you want this code to run at least once. So it seems to make more logical sense to just, why do we even need to initialize this response? Let's just do this code, and then at the end, see if their response is still yes. Okay, so the way that this is going to run now, since it's a do-while loop, the first pass, like as soon as the computer gets to this do, it's going to hop right in here and do this code. And then after it does this code, it will ask whether or not this condition is true, and if it is, it will jump back up to the beginning and loop. If it's not true, then it will exit the loop. So let's just run this and see that it's going to run the same way. So I enter 5, answer is 120. Again, yes. Okay, so I do it again, yes, and so on. Okay, then I enter no, and I break out of the loop. Okay, so just to emphasize what's happening here, suppose that for whatever reason I initialize response to no. Okay, the do while loop is going to run at least once. So even though response is no right now, if I run this code, it enters the loop, right? And it's going to compute. And let me go, right? You see? So a do while loop runs at least once. Even though the initial value of response is no, it's still going to hop right in here, and then at the end it's going to let you update your response. And after this update, it checks whether or not this condition is true. So again, just for emphasis here, let me go back to the original while. The original while said this: while response is yes. If I run this code, the first thing the program does is check whether or not the statement inside the parentheses is true. And in this case, it's false, right? Response is no. So when I run it, nothing happens, right? It doesn't even go into this loop because this condition is false already. Okay, so that's the difference between a while loop and a do while loop. So just for emphasis here, I have another example. You're writing a program that plays Hangman. If you want to use a while loop, you would have to initialize response to yes, and as long as the user says yes, you do the code, ask them if they want to play again, yes, whatever. But of course, if you're writing a Hangman program, you want to play Hangman at least once, so it seems to make sense to have code that guarantees that, so like built into the code. So do the Hangman code, and then at the end, ask them, do you want to play again, and see if they want to. Okay. So while loops and do while loops are very similar. The syntax is very similar. The main difference really is that there's a semicolon right here, and the while is at the bottom rather than at the top. For loops, though, the syntax takes getting used to. So let me just dive right into it. Here's what the syntax looks like. You have 3 things inside of the parentheses for a for loop. The first thing you do is give a variable a value. The second thing you do is you tell it the Boolean statement that you want it to check every time. So remember the way a loop works, right? It doesn't matter what kind of loop. It's going to run as long as a certain statement is true, right? So back up here, as long as response is yes, it's going to run, right? As long as response is yes, it's going to run. So the same thing is true for a for loop. You need to have a statement that the loop is going to check whether or not it's true or false. If the statement is true, the loop continues running. If the statement is false, you break out of the loop. And then you have a third thing called the update condition. So this is not terribly enlightening what I've done here, so I'm going to show you several examples, but keep in mind the logic here is still the same. It's a loop, so you have code inside of the loop. As long as this statement right here, this middle statement, as long as that's true, the code will keep running. It'll just keep looping. And as soon as the statement becomes false, you reach the end brace. If you reach the end brace and the statement is now false, then you break out of the loop. Okay, so let me show you a for loop. So when you initialize a variable inside of a for loop, which is what I've done here, I've created a variable called I, and I've set it equal to 0. What the computer does is it creates a variable specifically for this loop. So this little I here is specifically for this for loop, and once I break out of the for loop, this little I is destroyed. So it looks like I've created a variable here, and I have, but it's a temporary variable. As soon as the loop is done, this variable will disappear. Okay, so I've initialized the variable. I is now 0. I've given the loop a condition that it can check every time it asks, if it wants to restart or not. So as long as I is less than or equal to 5, this loop will run. This third condition here is called an update condition. So every time the loop runs, it's going to kick up the value of I by 1, because I wrote I++. Okay, so that's the logic of the loop here. I'm going to create a variable called I, and I'm going to set it equal to 0. And every time the loop runs, I'm going to up the value of I by 1. And I'm going to run the loop as long as I is less than or equal to 5. Okay, so initially I is 0. Well, 0 is less than or equal to 5, so I go into the loop, and I'm going to print high. After I do that, this counter here, this update, ups the value of I by 1, so now I is 1. Well, 1 is less than or equal to 5, so I'm going to print out high, etc. So I keep doing this until I becomes 6. As soon as I becomes 6, I now break out of the loop because this statement here is false. So this loop here will print high to the screen 6 times. Once for I equals 0, another for I equals 1, I equals 2, I equals 3, I equals 4, I equals 5. Okay, so here's another example. In this case, I've initialized I to 1. The Boolean statement is still the same. This time, though, every time the loop runs, I increase the value of I by 2. So the logic of what happens here is I is initially 1, and 1 is less than or equal to 5. So I enter the loop, and I print high. At the end of that execution, now I becomes I plus 2, so I is now 3. Well, 3 is less than or equal to 5, so I go into the loop again, I print high, and then I up the value of I by 2 again. Now I is 5, 5 is less than or equal to 5, so I run the loop again and I print high, and then I up the value of I to 7, and now this statement here is no longer true, so I will break out of the loop. So this for loop here will print high to the screen 3 times. Once for I equals 5, I equals 3, and I equals 5. So let's just walk through some more of these and talk about what they do. This for loop creates a variable I, sets it equal to 1. It's going to kick up the value of I by 1 every time. And as long as I is less than or equal to 99, this code in here will run, where I just print the I value. So I is 1, 1 is less than or equal to 99, so I enter the loop and I print out the value of I, which right now is 1. I print out 1, I print a new line, I kick up the value of I by 1, now I is 2, 2 is less than or equal to 99, so I print out I, etc. So let's just confirm that that's what's going on here. Just clear out all this stuff. So for int I equals 1, I is less than or equal to 99, I plus plus. Let's just go ahead and output the value of I and a new line. So notice, it does what we just said, right? So I go up, 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 up. The very first time the loop runs, I is 1, and then prints out a new line. I is 2, prints out a new line, etc. So the next example is the same, except now I equals I plus 2 is the update condition. So let's look at that. So if instead of kicking the value up by 1 every time, you kick up the value by 2 every time, well, the first time the loop runs, I is 1. But then the next time the loop runs, I will be 3. And then the next time the loop runs, I will be 5, etc. So it's not going to do 1, 2, 3, 4, 5. It's going to do 1, 3, 5, 7, 9, etc. All the way up to 99. See, 1, 3, 5, 7, 9, and so on. So it printed the first, so I printed all the odd numbers between 1 and 99 this time, not all of the numbers. Okay, the next loop. So now I set I equal to 1, and now as long as I is bigger than 1, the loop will run, and now I decrease the value of I by 1 every time. So this will start at 100, it will print 100, and then decrease the value of I by 1, so then I will be 99, and so on. And it will keep going until you reach I equals 2. So let's do I equals 100, I is bigger than 1, and decrease the value of I by 1 this time. So there you go. It starts at 100, decreases it by 1, decreases by 1, etc., all the way down to 2, right? Because it goes as long as I is bigger. Okay. This last loop here, it's worth thinking about what you think will happen here. What will this print to the screen? Well, let's talk through the logic here. I is 100, right? And the Boolean statement here, the condition on which the loop keeps going or not, is that I is less than 100. Well, if I is 100, the first thing the loop is going to do is check whether or not the statement is true, but the statement isn't true, right? 100 is not less than 100. So the computer is not even going to go inside the loop because you set it up so that it's false from the get-go. So this will print nothing. Okay, so one of the things that takes getting used to about for loops is trying to figure out how many times they'll run. So it's easy to miscount. So this loop here, I is 0, then I is 1, then I is 2, I is 3, etc., all the way up to 10, less than or equal to 10, right? So this loop will run 11 times. But sometimes people just see this 10 right here and just assume it's only going to run 10 times. Okay, so the loop starts with this I value and then just keeps going. Well, if it's upping it by 1, just keeps adding 1 to I and going until I is 10. So, 0, 1, 2, 3 up to 10, that's 11 times. So there are several common errors when using for loops, and I actually didn't mention one of them here, but the most common error is that these three statements here, they are separated by semicolons and not commas. Okay, it's very tempting to just write a comma right there instead of a semicolon. But no, you need to separate the statements by semicolons, not by commas. It's really not even worth mentioning that error because all of you will make it, right? But when your for loop won't run, that's the first thing you should check, is whether or not there's a comma right here. Okay, so here's some other common errors. Like I say, sometimes it's hard to see how many times your loop will run. So a lot of times your loop will run one too many or one too few times. Setting the wrong upper or lower bound for your counter variable, and the counter is just this I right here. It's the variable you create to run inside the for loop. So sometimes you set the wrong value right here, or if you're doing a lower bound, like right here, sometimes you mess up and you do something you don't mean. Okay, here's something you should never do. Never change the value of the counter inside the loop itself. Changing the value of I or j or whatever you decide to call this variable, changing that variable's value is what the update condition is for. So never change it inside the loop itself. If you want it to change, write it right here. Okay, it's extremely confusing to have an update condition here and then inside the loop itself have a statement like, I equals I plus 2 or something. Don't do that. And it's also easy to create an infinite loop. So let me just show you an example of what I'm talking about. So consider this for loop. Notice there's an I minus minus in here, right? That is bad, right? So if you all had shock collars, I would send a shock through you every time you did this, right? Do not mess with the I variable. Don't change its value inside the loop. Only change its value up here in the update condition. Furthermore, it's worth thinking about what do you think will happen when this loop runs. Okay, so it starts with I equals 1, and it's going to run as long as I is less than or equal to 10. Every time the loop runs, you're going to up the value of I by 1, right? But notice you also had a line of code here that decreases the value of I by 1. So every time you run this loop, You're going to print out high, decrease the value of I by 1, and then increase the value of I by 1. Okay? So every time the loop runs, the value of I will be 1. And if the value of I is always 1, well, 1 is always less than or equal to 10. So this loop will run forever. This is an infinite loop. And you should not be creating infinite loops. Okay, so that's an introduction to the for loop. So a natural question you might have is, well, I already know what a while loop is. Why do I need to know what a for loop is? You know, why have different syntax for basically the same idea, right? The idea of looping. And, well, first of all, let me address using a while versus a do while. We've already discussed this. Basically, you want to use a do while if you want the loop to run at least once. If you want that code to be guaranteed to run at least once, you should use a do while loop. Otherwise, use a while. So use a while loop if maybe you don't want to guarantee the code runs at least once. So the real question here is, since whiles and do whiles are essentially the same, how do you know when to use a while or a do while versus using a for? And this is actually a pretty difficult question to answer at the outset, because my answer to you is essentially, well, once you use both kinds of loops enough, you will come to realize on your own when you should use what. So sometimes using a for loop is just way easier than setting up a while loop, and vice versa. Sometimes it's way easier to do a while loop than a for loop. So that's really a non-answer, but it's the best answer I can give you right now. The more experience you have, the more you will be able to see when one kind of loop is easier to use or better to use than another. But here are some general guidelines. If you know ahead of time how many times you want your loop to run, it's usually better to use a for loop. So suppose you know you want your loop to run 5 times or 8 times or whatever. A for loop gives you that exact control. And of course you can mimic it with a while loop. I mean, it's not impossible to do with a while, but a for loop, the syntax is essentially set up so that if you know how many times you want your loop to run, it's just easy to do with a for loop. So that might not be a satisfying answer, so let me just give you another example where a for loop is better. So here's just a, I guess it's a probability kind of question, but suppose you throw 2 dice and you record what you see on each face. So, you know, you might see a 2 on one face and a 3 on the other. You might see a 1 on one die and a 4 on the other die, right? So if you throw 2 dice and record what you see, what are the possible outcomes? Well, you can see a 1 on the first die and a 1 on the second die, a 1 on the first die, a 2 on the second die, etc. Right? A 5 on the first die, a 3 on the second die. So in all of these ordered pairs here, the first number records what you see on the first die, and the second number records what you see on the second die. So this first row corresponds to all the outcomes where the first die is a 1, the second row, the first die is a 2, etc. Okay? So suppose you want to print something like this to the screen. You want to print this exact table here to the screen. How would you do it? Well, I suppose you could write 36 different cout statements, right? So cout 1 1, cout 1 2, cout 1 3, and so on. This is not optimal, okay? Especially like maybe you're not throwing 6-sided die. I mean, there are like 30-sided die out there, in which case this table will be way bigger, right? There'd be 30 rows and 30 columns now for a die that big. So you don't want to just hard code in every single output. So let me just show you an easier way to do this. So basically, let's just create a couple of for loops. And what each for loop is going to do is keep track of the different values on the different die. So I've just now created a variable called I, and it exists only inside this for loop. The variable I will correspond to the first die. So I will always be the first coordinate in one of these ordered pairs here. And now let's create another loop inside of this. So let's create a nested loop where now the second variable that I create, this j, keeps track of the second die, or the second coordinate. And so what I want to do is, well, I want to make sure this thing runs. Oops, sorry. So notice I have to say int j, right? I have to tell it it's an integer. I can't just write j. So what I want to do is I want to output the value of the first die. I guess I want a comma, right? And then output the value of the second die, and then I want to make sure I have enough space to read those different outcomes. Okay, so let's talk about exactly what will happen here. This outer loop starts when I is 1, right? I is 1, 1 is less than or equal to 6, therefore this loop will run. Well, when I is 1, the first thing you do is execute this code down here, right? This code down here says, well, I'm going to print 1 to the screen, followed by the value of j. So notice that in this code here, the value of I does not change. So if I was 1 right here, then I is always 1 right here. So this is going to print on the first pass-through 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, right? Because the value of j is being kicked up by 1 every time. Well, once the value of j reaches 7, I break out of this loop here, this inner loop, and I go back to the beginning of this top loop. When I go back to the beginning of the top loop, the value of I is kicked up by 1, so now I is 2. 2 is less than or equal to 6. So I enter this code here, and now I is 2, so now I'm going to print 2, 1, 2, 2, 2, 3, etc. Okay? And it's going to keep going until I get through 6 values of I. So let's just print that and see that it does that. And there you go, it printed all those outcomes. Notice that it didn't print exactly what I have here, and what I have here is nicer because it puts it in like a 6x6 table. So remember that on each pass through this top loop, this outer loop, on each pass through it's printing a single row of this table, right? When I is 1, when I is 2, when I is 3, and so on. So let's just have it. After it outputs all the values in a row, let's just start a new line. So now let's run it. And notice it looks just like I had over here. Okay, it's the same table. So doing this is not impossible to do with a while. You know, you can create a while loop that does this, but creating with a for is much simpler with these two nested for loops. So there's an example, right? So you just sort of have to take me at my word, I suppose, that that you just have to get used to using both kinds of loops. So if you're comfortable with both types of loops, then it's obvious to you that a nested for loop situation is better to print this than nested while loops, okay? But you don't get to that point until you use both kinds of loops often enough. Okay, so now we have seen all three kinds of loops that C++ has. We're not totally comfortable with them yet. It takes time to get comfortable with them, so we're going to build on these loops next time.